Hi guys, and welcome to this WACE Academy online lesson on Le Chatelier's principle. This lesson covers Unit 3, Chemical Equilibrium Systems, points 8 and 9. Today we'll go over how and why concentration and partial pressure affect systems that are in equilibrium. Then we'll look at a principle we can use to predict what's going to happen to an equilibrium system when we change parts of its environment, including temperature, concentration, partial pressure, volume, and catalysts. We'll also cover a few examples to show us how Le Chatelier's principle works in practice. In earlier lessons, we've talked about equilibrium, so we know that it occurs when forward and backward reactions in a closed system are happening at the same rate. Concentration and partial pressure can both affect the position of equilibrium, which means they can change the ratio of products to reactants. We can see how concentration affects the rate of equilibrium reactions by increasing the amount of collisions that occur. Partial pressure refers to the amount of pressure that one part of a gas, for example just the oxygen in air, is exerting. If the pressure is greater, similar to a higher concentration, this will also speed up the reactions occurring. But hang on, just speeding up both sides of a reaction won't make there be more products or reactants than before. So why can we change their proportions using concentration and pressure? This can be explained by Le Chatelier's principle. Le Chatelier's principle states that if we change the conditions of a reaction, the reaction will respond to counteract the change. In other words, if you make any change to the conditions that an equilibrium is happening in, the equilibrium will shift to counteract the change. Don't worry if that doesn't make any sense yet. After we see a few examples, it'll get much more clear. So let's see what happens if we increase the temperature of a reaction. We'd guess that it would go faster both ways. But actually, if one of the reactions is endothermic and one is exothermic, the endothermic one will speed up, absorbing the excess heat. That means that the equilibrium will favor the products of the endothermic reaction and shift towards the side that the products are on. On the other hand, if we lower the temperature that an equilibrium is occurring in, the exothermic one will speed up to create extra heat to compensate. That means that the equilibrium will favor the products of the exothermic reaction. Alright, now that we've covered temperature, let's go back to concentration, which we were talking about earlier. Let's picture a reaction. A plus B forms C plus D and vice versa. If we reduce the concentration of C by taking it out of the system, the reaction would compensate by moving towards C and D to create more C. Likewise, if we added a lot of C, it would shift back and create more A and B to maintain the concentrations. We use this a lot in industrial chemistry when we're making lots of a certain product. If we keep removing the product, we can get more and more of it from the system, wasting less of the reactants. The effect of pressure in gaseous reactions is similar to this. Picture a gaseous reaction where one side has A and B and the other has just C. If we increase the pressure on the system, the reaction is going to try and counteract this by reducing its own concentration. The easiest way for it to do that is to shift towards the side with less products, which is the side with C. Again, the opposite is true as well. If we reduce the pressure, the reaction would favor A and B to maintain its concentration. Our next factor, volume, operates in exactly the same way. An equilibrium that is given a smaller volume will shift towards the side with less products, and vice versa. Now, catalysts are included in this dot point, but it's a bit of a trick question. The use of catalysts can't actually affect the position of equilibrium at all, so we can't apply Le Chatelier's principle to it. This is because if we add a catalyst, it will speed up the forward and backward reactions the same amount. So both reactions might be going faster, but they'll still be going at the same rate proportional to each other. Alright, that's the end of our content for today. This lesson we covered: concentration and pressure can both affect reaction rate because increasing them also increases the number of collisions in the system. Le Chatelier's principle states that if a change is applied to a system in equilibrium, it will respond to counteract the change. We can use Le Chatelier's principle to predict what will happen to an equilibrium system when we change temperature, concentration, pressure, or volume. Catalysts do not change the position of equilibrium, and are not covered by Le Chatelier's principle. Alright, that's it for today. Next lesson we'll talk about the equilibrium constant K. Thanks guys, and see you next lesson.